Now we're going to talk about angles in standard position in all quadrants. So if we look at our diagram, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. When we are in quadrant 1, our x value is positive because we're going positive x, and our y value is positive because we're going positive y. In quadrant 2, we're going negative x and positive y. In quadrant 3, we're going negative x and negative y. And in quadrant 4, we're going positive x and negative 4. We have reflections of these points on our graph. So if we were to say we wanted to find the point that reflects across the y-axis and mirrors the point P. So that means we want to mirror this point right here and reflect across the y-axis. So our matching point would be P prime. And our little apostrophe is a prime. If we were reflecting across the y-axis and mirroring point P double prime, this is our P double prime, and we're going across the y-axis, so our point is P triple prime. If we were reflecting on the x-axis and our point was P, so this point across the x-axis, our mirror image would be P triple prime. And if we were reflecting on the x-axis, mirroring the point P double prime across the x-axis, our mirror image would be P prime. A reference angle is the smallest angle that the terminal arm makes with the x-axis. So first what we need to know is how many degrees are on each of the axes. So right here we have 0 degrees, this is 90, 180, and 270. And then all the way full circle is 360. So the reference angle goes from the x-axis to the line. If we wanted to draw a reflected image in quadrant 2, our line would look like this. And this angle from the x-axis to the line would be 30 degrees. If we wanted to draw it in quadrant 3, it would look like this. And from the x-axis to the angle is 30 degrees. And in quadrant 4, from the x-axis to the line is 30 degrees. What we now want to see is how much degrees each of these angles are. So how many degrees is this, this, and this? So to find that, we're going to take, for quadrant 2, we're going to start at 180 and subtract 30 degrees because we're going up from 180. So 180 minus 30 equals 150 degrees. So this angle right here is 150 degrees. This is how you always find your angle in quadrant 2. For quadrant 3, we're already going 180. So we're going to go 180 plus your angle, which is 30. So our answer is 210 degrees. So this angle right here is 210 degrees. And this is how you find quadrant 3. For quadrant 4, all we have to do is take 360 and subtract our angle, which is 30 degrees, and we get 330 degrees. So this angle is 330. The similarity between all four of these graphs is that they all have the same reference angle of 30 degrees. So you can write a reference angle of 30 degrees in all four quadrants. If we're given an angle, we can find what the reference angle is for that angle. So what we're going to do is we're going to first decide which quadrant this angle is going to be in. So we know that the angle is less than 180 degrees, but it's more than 90 degrees. So it has to fall in this quadrant, quadrant 2. So our angle is going to go in here somewhere. To find the angle, we're going up from 180. So take 180 degrees, subtract 170 degrees. So we know our reference angle right here is 10 degrees. For 240 degrees, we know that this angle is less than 270, but greater than 180. So on our graph, it's going to have to lie in quadrant 3 somewhere. So to find this, we're going to take our angle, because we're going up to 180. We take our angle, subtract 180 degrees. So we want to find out what the angle is without this area. So we get 60 degrees. So our reference angle is 60 degrees. For 335 degrees, we know that this is less than 360 degrees, but greater than 270. So it's going to have to lie in quadrant 4, somewhere in here. So we're going up from 360 there. So we're going to take 360, subtract 335, and we get our answer to be 25. So our reference angle is 25 degrees. We can also compare our primary trigonometric ratios with our reference angles. So if we take quadrant 1, we know that this is our y and this is our x. So sine theta equals y over r, cos theta equals x over r, and tan theta equals y over x. All three of our ratios are positive. If we go to quadrant 2, our y is positive and our x is negative. So sine theta equals y over r, same thing. Cos theta equals negative x over r. So now our cos is negative. And tan theta is equal to y over negative x. So our tangent is also negative. So the only thing that is positive in quadrant 2 is sine. In quadrant 3, our x is negative and our y is negative. So we have sine theta equals negative y over r, cos theta equals negative x over r, and tan theta equals negative y over negative x. And because both negatives make a positive, our tangent is actually positive. So in quadrant 3, tan is positive. That's terrible. For quadrant 4, our x is now positive, and our y is negative. So sine theta equals negative y over r. Cos theta equals x over r. And tan theta equals negative y over x. So the only thing that is positive is our cosine. We can see that we have one positive value for 3 of our quadrants, and then in quadrant 1, all of them are positive. An easy way to remember this is cast. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, all of them are positive. In quadrant 2, only our sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cos is positive. So we make the word cast. C-A-S-T. So for example 2, we want to find the trig ratios for the point B is negative 2 and negative 4. So first thing we do, let's draw a picture. Because our x is negative 2 and our y is negative 2, we know that it's going to be in quadrant 4, or 3. So we're going to have a line here. Our x is negative 2. And our y is negative 4. So it should look something like this. We want to find our r. So we need to use r is equal to the square root of negative 2 squared plus negative 4 squared. Negative 2 squared is 4, plus negative 4 squared is 16, so 4 plus 16 equals 20, so the square root of 20. So we know this length is root 20. So sine theta is going to equal, so if we look at our angle, this is our angle right here, our opposite, so negative 4 over our hypotenuse, which is root 20. Cos theta is going to equal our adjacent, which is negative 2 over our hypotenuse, which is root 20. And tan theta is equal to negative 4 over negative 2. So tan theta is equal to 2. If we want to find our angle, we use any one of those, so let's do tan theta is equal to 2. So theta is equal to tan to the negative 1 of 2. And if you type that into your calculator, you should get, to the nearest degree, 63 degrees. So that means that our reference angle is 63 degrees. So from the terminal arm to the x-axis is 63 degrees. We want to find what the entire angle is. So to find this, we're going to have 180 plus 63 degrees is our theta. So theta is equal to 243 degrees.